All right, we're talking about parallel and perpendicular lines today. Just a refresher in case you forget. Parallel you should know. Parallel is when you have two lines that will never touch each other. They're going at the exact same angle, so if you extended them forever, this is a sketch obviously, right? They will stay going the same angle upwards, which means that if there was like 10 centimeters between them there'll always be 10 centimeters in between them. They're always the same distance apart. That's what parallel means. Perpendicular is the opposite. So that is when you have two lines that intersect at a 90-degree angle. Okay, they make that T shape. Parallel, perpendicular. So what we need to know is how we can tell if lines are parallel or perpendicular. If we have a protractor, we can figure it out. But if we don't have a protractor, we need to be able to do it, especially with graphs. So are these two parallel or perpendicular? The way we can do it is by using slope, which is why we've spent so much time talking about slope in this unit, because slope can be really helpful for identifying patterns. So in parallel lines, actually no, we'll talk about that after, but we're going to use slope. So if I look at these two lines, they're obviously not parallel. I know they're not parallel by looking because they touched, okay? If two lines are at different angles, so like let's make a less comical example, they're not touching. So are they going to be parallel? I know the answer is no, because you can tell here they're pretty far apart, but then here they're a lot closer, which means if I extended it, they're eventually going to cross maybe somewhere up there or something, okay? So the only way that two lines are parallel is if they're going up the exact same amount. And that means using slope. So slope is basically the speed at which a line increases, or how steep is the line. So if we want something that's never going to intersect, it needs to have the same slope. Because that means that they're going up at the same angle. So this one, you can see the slope is over 1, up 1, so the slope is equal to 1. So if I wanted to have a parallel line, I would have to make another line that has over 1, up 1. So if I can see these two lines, and you can tell just by looking, they're the same amount of distance apart the entire time. They both have the slope equal to 1. That means they are parallel. Let's look at this one. This slope, we go down 4 over 2. So this is 4 and 2. So if I said, okay, my slope is going to be 4 over 2 is equal to 2, and then I draw another line which has a slope of 2, you go like, whoa, wait, that's intersecting, that doesn't make any sense. This is where you can easily see a mistake, a common mistake you make. This line is going down, so this would be -4, which would mean that the slope is -2. So if I had to draw another one that would be parallel, it would have a slope of -2. So this line and this line would be parallel, because they would both have the slope of -2. So if they have the same slope, parallel. If their slopes are in any way different, so if I had a slope of one line is equal to 4, the slope of another line is equal to 4.1, they are not parallel. They will cross at some point. Might take a while, you might have to extend the graph, but they will cross. Now, perpendicular is a little weirder. Let's draw two examples, okay? These two lines are obviously a 90-degree angle, okay? The green one and the red one. There's a 90-degree right there. I want to write the slopes of those right now. So let's do rise over run for the red line, okay? Rise over run. So the rise from this point to this point, well, it doesn't go up anything, it's 0. And the run is like, I don't know, 7. So 0 divided by 7, the slope is 0. Now over here, let's do the same thing. So let's go this point and this point, so same thing, -4 and 3. The rise and run, the rise here is 7 and the run is 0, and so the slope is undefined because you can't divide by 0. Now just look at these two numbers and hopefully you see something happening. We'll talk more about it in a sec. Now I drew two more lines that are obviously intersecting at a 90-degree angle. So I drew one that's going like diagonally up and then diagonally down. It's pretty clear to see this would form a 90-degree angle. Again, let's write the slopes. So the slope of this first one, rise over run, so it's going to be 1 over 1, that's equal to 1. The slope of this purple one, rise over run, so it's going down 1 across 1, so it is -1 over 1. So that's going to be -1. So now looking at these, we can actually see a pattern. So if I was just given these two slopes, this slope and this slope, what do you notice about those two? Well, they're very similar. One's just flipped upside down, right? It went from 7 over 0, and then the other one was 0 over 7. So you notice that there's like a flipping happening. Over here, the slope went from 1 to -1. So what was happening here was you were multiplying by -1. So the truth is, both of these happen every time, okay? If you have a slope of a line, like let's say this one, we said it was 7/0, in order to find the perpendicular slope, you multiply it by -1 and you flip it, which is called reciprocate. Okay, that's the math word, flip a fraction upside down. So we are given slopes in lots of situations. So like, let's take this line, okay? The slope of this line would be 4/1. So if I wanted to find the reciprocal, I need to multiply by -1. So it's going to be a negative slope. And then I need to flip these upside down. So it would be 1/4. So the slope of the perpendicular line would be -1/4. Let's sketch that just so we can see it. Again, it doesn't matter where we do it from because it'll be perpendicular no matter where it starts. Let's start from like here. Okay. So -1/4, so -1 means down 1, and then across 1, 2, 3, 4 to there. And then we're going to draw it with a ruler so it's easier to see. I really should draw this one with a ruler. If we look at those two lines, they do form a 90-degree angle. And let's see if we can tell using our, no, it's so hard. This protractor is so bad. Okay, it is a 90-degree angle. So it doesn't matter what slope you have, any slope. You take what it is, you multiply it by -1 and reciprocate it. So let's just do one more example together and say the slope we got was 3/4. The parallel line would also have a slope of 3/4. Okay, that would be parallel. That means that they're both going up slowly. If I wanted the perpendicular, you would have to take the 3/4, you flip it, and you multiply it by -1. A lot of students forget the negative, but I think it makes a lot of sense because if you take any graph, okay, if I draw that's the first line, the line that's perpendicular is obviously going to have to go like that. If this was a positive slope, this slope has to be negative. That just makes sense no matter what situation you have. The only situation this doesn't happen in is this one over here where you have the vertical lines because there is no negative version of 0. So that one doesn't matter, okay? But so the core takeaway that we have here, parallel lines have the same slope. Perpendicular lines have negative reciprocal slope. So if this was the m is equal to 5, parallel line would have the same slope. Perpendicular lines, if the m is equal to 5, be careful, this is like 5/1, right? The perpendicular slope would be -1/5. And that's it.